Hi, I'm Kratz, Principal Engineer at Bazaarvoice, and today I'm going to make each and every one of you feel like you're working in 2024. AI's transformational potential has permeated our zeitgeist, and everyone expects it will change the way we live and the way we work. But I ask you, what has changed for data scientists and machine learning engineers? How many of you feel like you're working in 2024? And I like to make there we go. So today, I'm going to show you how Evals, a technique for validating generative AI output, can speed up your workflow, unearth insights about your model performance, and even eliminate data labeling from your job. And I know this is a big promise, so I'm going to share real-world examples of Evals doing those things at Bazaarvoice. And along the way, I'll demo how the Arize platform and their open source tool Phoenix enables you to make it easier to create, run, and analyze the output of evals. So to truly understand why evals are important, I think it helps to look at them in the context of how the machine learning field has changed over the last 5 to 10 years. This context is solely my perspective, so I think it helps to start with a little bit about where I'm. I like to make AI stuff. I started off in academia, got my PhD in 2012. That's right, I got a fancy computer vision degree right before convolutional neural nets made it big. So I was a little early. But if you were in the field at the time, you might recall that deep learning was just getting hyped. We needed millions of data points to train a model, but they could generalize to new data with an accuracy that finally made them commercially viable. This is when the business folks started to pay attention. This is also when I got my first job. Out of academia, I started at a marketing startup called Curelate. And startups are pretty much trial by fire. And we struggled early on to get value from machine learning. And we weren't alone in this. You might have seen this article from VentureBeat about how 87% of data science projects weren't getting into production. And it was bad. Everyone wanted a piece of the deep learning pie, and nobody knew how to pull it off. After a while, the startup I was at succeeded at this, but it was mostly through brute force and sheer will. And being a startup, we cut a lot of corners. Then in 2020, Curelate was acquired by Bazaarvoice. And if you'll give me a minute for a slight deviation, I'll explain what Bazaarvoice does. So Bazaarvoice provides software that lets customers post reviews, videos, images, and questions and answers to e-commerce websites. This builds trust between consumers and brands by making the shopping experience more transparent. Consumers know what they're getting, and that results in an increase of sales for our clients. And as you can imagine, there's ample opportunity for machine learning to add value here. And when I came on in 2020, Bazaarvoice was using machine learning to moderate user-generated content, extract sentiment, and automate our clients' workflows. They had a large number of models, probably over 400 of them, including the ones that came on with me from Curelate. They were all haphazardly trained by different people, deployed in different ways, and had zero transparency. In other words, Bazaarvoice had fallen victim to the risks of machine learning tech debt warned about by Google. Fortunately, by 2020, the field of MLOps was nearing maturity to respond to this problem. And I suspect this diagram is not new to many of you. And in 2021, Bazaarvoice alleviated their tech debt by adopting an MLOps process and platform. And this worked pretty well for us. We could train models with reproducible pipelines, validate them in the cloud, and deploy and monitor them easily. In other words, life for the data scientist and machine learning engineer was not bad. Then in 2022, a small little app came out that changed quite a bit about our work. And the interesting thing about ChatGPT wasn't its capabilities. GPT-3 had been around for a while. It was how it permeated the zeitgeist and got everyone excited about AI's potential. And if you're like me, your job shifted at this time from individual contributor to an educator and leader tasked with finding competitive advantage using LLMs. And this was pretty fun. We heard about generative AI models, but we hadn't gotten our hands dirty yet. So I thought, let's see what these things can do. If you remember, Bazaarvoice curates user-generated reviews for e-commerce websites. And some products have like thousands of reviews. So it was time to read 1,000 reviews. So we wanted to see if a large language model could create summary of reviews for the consumer. You've probably seen Amazon's version of this on their website or app. And it's pretty straightforward, right? We simply prompt the model to summarize all the reviews, and it generates a result. This would let consumers digest the wisdom of the crowd in just a few seconds. And this was pretty exciting for me. The big thing that stuck out for me was I didn't have to label any data, right? Coming up from deep learning, this is like great. And this tracks if you look at historically what had happened over the last 10 years. 10 years ago, we needed millions of data points to train a deep learning model. Then with transfer learning and fine-tuning, that number reduced to tens of thousands. And now with foundational models, we can use little or even zero data to solve a data science problem quickly. But there's a major problem here. How do we know our summaries are good? Remember, these summaries are generated by AI. We don't have any indicator of their quality. But it's easy for us as humans to enumerate some quality characteristics. So this is what we come up with at Bazaarvoice. First, we wanted to ensure the summaries don't say anything inappropriate. Remember, these are generated from reviews written by consumers, so it's possible inappropriate or toxic material could slip in, past our moderators, and end up in the summary. Second, we wanted to ensure that the summary is faithful to all of the reviews. It should fairly capture the sentiment and information from each person equally. And finally, we should check some presentation characteristics such as length and tone of voice. So it was really easy to write these things down. My product manager had no problem. But how do you actually check for these results, right? And we thought, well, hey, we've already solved this problem to some degree. Remember, at MLOps, we have a very rigorous and well-defined test step, right? What we need to do is validate our model. And just because our model's a prompt doesn't mean it's not a machine learning model. The prompt is a model, and we should treat it like one. The only difference is that the prompt output is unstructured. Instead of a numeric vector, we get an unbounded sequence of words. Now, obviously, I could just have humans go and look at these unbounded sequences and tell me whether or not it's a good summary. But this is time consuming. In fact, I asked some humans to do this at Bazaarvoice early on, and it took them 16 hours to moderate 1,000 generated summaries. Not so great. And this is just data labeling all over again, right? It's like we're back in 2012 labeling data for deep learning. But it's 2024. So like our CEOs are saying, hey, can't AI do it for us? Well, that's exactly the key idea behind Evals. It's a machine learning model that evaluates your generative output. The challenge here is writing a prompt that measures what we care about. So let's look at how we can build an eval prompt. First piece of an eval is the system prompt. This sets the persona, just like you do in other prompts. I personally like to throw in data scientist, labeler, analyst, something that indicates some precision. Next, we provide the prompt with a generative output from the previous LLM. That's what it's evaluating. Thirdly, we add contextual information necessary for the LLM to judge the generative result. This is often source material passed to the generative prompt that it needs to be able to look at the result and understand it. Next, we simply describe the task at hand. And we can also provide some grading criteria. We'll cover this in a little bit later, but it should clarify exactly how the LLM should grade your result based on various inputs from you. It's really an expert system here, right? Next, we'll provide some examples. This makes it a few-shot learner. You can omit this if you want. We'll see an example later that does that. but obviously including some examples will make your results more accurate. And finally, we specify the output format. We want to say how the response should be structured. So that's a lot to take in. I got a lot of colors on that slide. Let's see an example. This is an eval from the Phoenix open source library that identifies if an AI response is racist, biased, or toxic. This is a great eval to run. Ensuring your application isn't harmful should be your first requirement. And this eval is rather simple, but it does include a lot of the pieces I just talked about. So you'll see at the top, we have the system prompt. It sets the role. It's not exhaustive, but it could be more specific. It's all right. Next, the generated text is included. There's no extra context included in this one. We're assuming that LLM knows what harmful means from its training. And this is reasonable. But as the language evolves, you might need to start including examples of new slurs or insults as people start using them. And it clearly defines the task. Pretty concisely, actually. Thought I did a good job of that. The grading criteria is specified, but examples are omitted for zero-shot learning here. So no examples included, that's all right, we can do that. And finally, the output format is provided. A label that indicates toxic if it's harmful, and non-toxic otherwise. So it's a lot to take in, but it's not too bad. And this toxicity eval is a perfect fit for our review summary use case. Remember, this was our first quality objective, ensuring that we aren't posting harmful material. The eval creates a single label on a single review summary. That's great, but to truly measure our system, we'd like to understand how it performs holistically. And just like validating traditional machine learning models, it's best to evaluate a large set of generative texts that represent the population of possible outputs and aggregate the results. So this way you can get the take-home picture of what's going on really quickly. Obviously, this involves a lot of LLM calls, but like machine learning validation, you can do this offline in batches. And you're probably thinking, oh, this sounds great, Lou. All right, I'm ready to get started. How do I do it? Well, the Phoenix library actually makes this really easy. You can provide the eval and your input data, and it'll parallelize with asynchronous calls to the LLM to get high throughput and evaluate our results in a matter of minutes. This example, I did 100 in under, about 48 seconds. It's pretty good. And after evaluating, you can view the generative text and eval results in the Phoenix UI, in the Phoenix Web UI. And what I really like about this is that it shows you the aggregated statistics up top. So if you've been listening to me this talk, this is amazing, right? In 4 lines of code, we've validated that our generative model doesn't produce toxic results. The one toxic percent that isn't there, I hard-coded as a check, just to see that pop up there. So you can see your aggregated results immediately, and then dive deep if you need to. This is how you can ensure your generative models are performing well before you ship them. This is letting AI do the heavy lifting for you. This is how we can work in 2024. But there's a large elephant in the room I haven't addressed yet, and if you're sharp, you might have picked up on this. We're using a machine learning model to measure the output of another model. But how do we know if our evals are accurate? We need to evaluate our evals as well. This is where benchmarking comes in. Benchmarking measures the accuracy of your eval with ground truth results. Now I know what you're thinking, Lou, you promised we wouldn't have to label data anymore. But hear me out. The amount of data you need to label here is actually pretty low, just a few hundred. And then you can reuse your eval in all of your applications really, really quickly. So once you've proven to yourself it works, you can spread it around as long as you made it generic enough. And benchmarking task usually pays for itself very quickly, unlike deep learning where you pay thousands of dollars and it would take a year or so. This pays for itself almost certainly. Also, Phoenix has done this for you. They've run their evals using public open source data sets on many common LLM tasks, such as retrieval augmented generation or detecting harmful results. So you can use those because you know they work, or write your own and benchmark it yourself. But I would not recommend skipping this step, because if you do, then you can't really trust your eval. But if you don't skip it, you can trust your eval entirely. And when you benchmark it, you're likely to find examples that produce unexpected results. This is often due to a disconnect between the words you've used in your grading criteria and what the LLM thinks those words mean. This happens to me all the time. I'll use a word like quality, and it'll think, well, there's no punctuation mistake, so it's high quality, right? And this can be pretty tricky to debug because the LLM operates like a black box. But we can actually just ask the LLM to explain their result. Now, in addition to the output label, we'll get a justification as to why that output was provided. This can provide great insight into why the eval grades a certain way and guide you in refining your eval result during benchmarking. And Phoenix supports explanations out of the box, and visualizes them in the UI. So if you click through on a specific data point, you can see the explanation and understand why it was applied. This makes it extremely easy to track down problems and correct them. So another topic I'd like to touch on is the difference between grading criteria you can use. I've seen 3 in practice. Most common is binary, 2 possible outputs. The toxicity one was a good example of this. And binary outputs keep things pretty straightforward. It's a good practice in general while writing your own evals. The next one's categorical. In this case, the output's selected from a fixed set of labels. This has the advantage that you can be very specific about what each label means when you're creating it. So for example, you might see the numbers 1 through 5 or A through F, like letter grades. It's pretty good. And then you can look at the distributions of the outputs to better understand how your models perform. The last output type you'll see is numeric. In this case, it's usually a number between 0 and 1. Do not do this. I see this around, but LLMs have demonstrated time and time again that they're bad at math. And if they're bad at math, I can't really trust it to discriminate between 50% and 55%, right? So instead, I recommend using categorical and just casting it as a number and taking the average and being able to aggregate the results. If you ask for a confidence interval, things are going to go pretty poorly. Okay, so now that you have the basics, I'd like to share some best practices that we found at Bazaarvoice that helps us create evals quickly and reliably. First, make them as dead simple as possible. This will reduce the risk of failure and allow you to iterate quickly. Keep them short and simple. Next, be sure to provide the context necessary to the eval to grade something fairly. For example, don't just ask, hey, is this a hallucination? Give it all the stuff that came out of your RAG system as part of the input and the result, and ask if they align. Ask if any words don't make any sense. That's a hallucination. It won't be able to discern between hallucinations and real generated text on its own. Thirdly, use multiple evals and aggregate statistics to infer more complex behavior. Do not cram everything into one eval. It'll only make the LLM's job harder. And if you do use separate evals, you can slice and dice the data to truly understand the results. You can look at correlations. Fourth, and I know I said this before, do not use numerics for grading criteria. You won't get good results asking an LLM for a confidence percentage. And as with any generative AI application, if you're having trouble getting good accuracy, provide some examples. Few-shot learning is almost always more accurate than zero-shot. And finally, this is probably the most important one that no one talks about. Read the formatting guidelines for the LLM you're using and follow them. GPT-3 and 4 like Markdown, and Claude likes XML. We didn't do this at first, and we were using Claude. We were trying to use the evals we got from Phoenix, and nothing was working. The minute we rewrote the prompts to work with XML, I got 0 parsing errors and could eliminate all that Rails code that people see to try to pull things out. Spits back the XML in a perfectly parsable result. OpenAI now has like function calls, so you can get it back in JSON as well. Also a really good idea. So, see what the language model suggests you do in terms. Okay, so you've seen how eval works and how easy they are to get going in Phoenix, but it would be silly of me to give this whole talk and not show you some of the features that Copilot has at Arize that Jason was talking about earlier today. The first feature summarizes your results. So if you go to that little Copilot thing and just say, summarize my eval. You give the eval name. It'll generate this whole document that tells you what the eval is doing, a summary of the data points, and why. So this is really great for getting a holistic view of when your data scales and your complexity increases. It really breaks it down for you. I thought this was fun. I'd like to pass these to my product manager. The next feature suggests existing Phoenix evals based on your data. So here you can see it'll correctly identify that I was doing summarization and suggest I run the summarization eval. So that's pretty cool. Thank you. I like that a lot because I tend to forget everything. And finally, one more interesting Copilot feature is its ability to create evals for you based on your data. So here I asked it to make an eval that looks for specific camera-ready characteristics. That was my third quality check. And it's going to generate a JSON blob that I can just pass its KW args into Phoenix. The video, there we go. A little bit of latency. Obviously, I still recommend you benchmark that, but it's cool to get going there instead of working from a blank page. Okay. So at Bazaarvoice, evals are the crucial piece to ensuring we can ship generative AI products quickly and with confidence. And the benefits here are many. I'd like to share some of our outcomes we've seen after adopting. For review summaries, the time to validate models went from 10 hours to about 6 minutes. It also costs about 1,000 times less, since the LLMs are rather cheap compared to human labelers. Don't worry, we didn't fire anyone, we just give them better value-adding work. In addition, we can run them live during inference as guardrails to ensure that the results aren't harmful in case we miss something. And finally, we can use evals to compare each summary to every single review to ensure we're remaining faithful to the opinions of the crowd. This protects the integrity of the product and us as a company. Another place we use them heavily is whenever we're building a retrieval augmented generation system. If you're familiar with these, you probably use Llama Index or LangChain, both of which have good support in Phoenix. And as you saw this morning, now we're like getting really close together. And using evals and RAG can really help you track down which part of that RAG system is underperforming. It's retrieval or the ranking or things like that. In addition to using evals for our employees, we've even productionalized them into a product for consumers. So we recently released this feature called Content Coach that validates if a specific topic was covered in a product review while the consumer's writing it. So this is awesome. It gives consumers a way to help them write more faithful reviews. It's basically a real-time eval at scale. And finally, we've also found success using evals for non-NLP tasks. Specifically, we use Claude 3 with the computer vision stuff. And we found we can eliminate the need for human labelers on many of our image tasks, including like labeling pairs for embedding training. You can even use it to check for stable diffusion artifacts. We did on a few occasions. So I hope I've not only shown you how evals work, but convinced you they're a fantastic tool for validating your generative AI models. Use them, and you will feel like you're working in 2024. Thanks.
Yeah, we have a couple minutes for questions.
Yeah,
We got to go around the room.
Yeah, sure.
Hi there. Can you say a bit more about the numeric gradient? Like why you would recommend that? Like what are the specific downsides?
I'm sorry, could you repeat that?
The numeric gradient you said you.
Oh yeah, the numeric one. Yeah, avoid that.
Similar.
Yeah. So remember, LLMs are really good at predicting the next word or words, right? That's all they're really doing. Is like trying to tell you an answer that they think looks right from a natural language perspective. They can't reason about what's the difference between 0.55 and 0.56. So if you're asking it to pick one of those, it's going to hallucinate. And you'll see this time. In fact, I think someone at Arize did a blog post about this. You can look at the distribution of scores and it's just all over the place. But if you give it like, hey, A is this, B is this, C is this, it can line up its answer with that exact criteria, and you discretize and quantize it into that bin. That's what you want. It forces you as the writer to be more specific about your grading criteria. That's okay. You should think about that anyway. So yeah, it's just better all around.
That Warner did that blog post, remember?
Yeah.
Yeah, thank you. Great presentation.
For budgeting our LLM costs, if we're calling a frontier model for the summarization case.
Yeah.
How much of my budget is going towards the summarization and how much goes towards my evals, making sure everything's.
Yeah, so I want to separate the idea of using evals offline and online. Online, it's a guardrail. You do that to ensure it doesn't, get big. I would look at your budget there and see if you can get them all to do that, because you want to be safe. Offline, I'd argue that budget shouldn't even exist, because you are more expensive than a large language model, right? So what's your alternative use case? You can have humans do it? No. And it's an offline, it's a training and validation process. So even if you're doing it over 10,000 calls, like 10,000 calls to an LLM is like a couple of bucks. It doesn't add up very high. Even if you're, and the costs keep going down. So like the scale only really matters at that live serving part. And that I hope you have talked to your product managers about to know whether or not it's going to have a positive return on investment before you build it. So yeah, I would play the usual budget games you do. Remember, humans are more expensive than machines, and I have not hit the problem as much as as I thought I would. And when I did, we just said, well, we're going to distill a model for the inference part, for sample.
Looks like summarization.
Yes, yeah, you do. Yeah, so whenever you have your generative output, that's one LLM call. Then for each eval, you gotta do another prompt and output. Yeah, right. So you're 4x your costs.
You're saying I'm not running all three of those evals every single.
It's totally the use case dependent. We will probably run the toxicity one on every generation and not the the faithfulness one and stuff like that, because that one will sample down.
Probably have time for one last question.
So for the multiple eval in one prompt, how you solve in one prompt template, how you solve problem if there are eval results are missing? You have 3 evals in one template, but only receive 2 results.
Never put 3 evals in the same prompts. 3 different prompts for each eval.
Yeah, because they have latency when you do that.
I mean, that's fine. You can pull in your thread manager and still call it concurrently.
Yeah, because I see you have the PPT say eval 1, 2, 3, 2,
Yeah.
like that.
Yeah, they don't have to be sequential though. So like, here we go. Yeah, so I have 3 evals. I'm going to use 3 different prompts to make 3 calls to my LLM. I can just parallelize that. Latency is the same, but I have all my scored results. But as I mentioned, like most evals we're doing offline because it's part of our test and validation phase. Whereas when we shoot it live, it becomes a guardrail, technically the same. And that is usually handled, you can still parallelize.